Ready to dive deep into some cool AI stuff? Today we're getting into neural networks,
We's fun.
but
Yeah.
with a bit of a twist. We're tackling it all with Pascal.
Really?
Yeah,
Wow.
Pascal. The programming language known for being clear and readable. It's now like powering these really sophisticated AI apps, all thanks to something called the K-CAI NEURAL API.
Yeah, it's really interesting to see this development. You wouldn't really think of Pascal as like a major player in the AI world,
Right.
but this API is really challenging that assumption.
Yeah. It's like finding a vintage typewriter that can run the latest video games or something.
Yeah.
But why Pascal?
Yeah.
And why this API? Well, the documentation, it kind of lays it all out. Pascal is easy to use.
It's true.
Which makes it great for new programmers and those who've been doing it for a while.
Absolutely.
And let's be honest, who doesn't want to write code that's powerful but also easy to wrap your head around?
Especially in AI. I mean, that's a huge advantage because things can get so complex so quickly. And it's not even just about readability. This API also gives you super fast native code execution. That means your AI models, they can run at lightning speed.
So we're talking speed and readability.
Yeah.
That's already a winning combo in my book.
Right.
But it gets even more interesting. So this API, it might actually be able to outperform some of the big names out there, especially when it comes to certain neural network architectures.
Really?
Yeah, we'll unpack what that means a little bit later, but it's safe to say this Pascal API is packing some serious power.
Yeah, it really is. It shows you what you can do with some really smart design and using the strengths of a language like Pascal.
Now, I know what some listeners might be thinking. Hold on, isn't Pascal mainly used with Lazarus?
Yeah, it's a common thought.
And it's true. This project, it is Lazarus-based. But here's a cool thing. A lot of the code is actually compatible with Delphi, specifically from version 0.98 and later.
Right, so even if you're coming from that Delphi world, you can still tap into what this API can do.
Exactly. It's about making AI open to everyone, not just a select few.
I like that.
So we've established that Pascal might be like the dark horse of AI development here. But what can we actually build with this thing? Like, what kind of neural networks are we talking about?
Think of the K-CAI NEURAL API as your AI toolkit. It gives you all these different parts you need to build all sorts of neural networks,
Okay.
from simple ones all the way to those more complex structures.
So you're not just using pre-made models, you're building from the ground up, which is cool. But is it beginner-friendly? Because I don't know about you, but building a neural network sounds pretty intimidating.
I hear you. That's where this API really shines. It's made to be practical, hands-on, even for people who are new to AI development.
Okay, that's reassuring. So what makes it so approachable?
Well, the documentation is super clear and easy to follow. It walks you through the entire process.
Nice.
Starting with a really straightforward installation.
No, like wrestling with dependencies for hours?
No, not at all. And once you've got everything set up,
Yeah.
they give you these really easy to understand examples right there in the documentation to get you going.
So it's like a cookbook for neural networks.
Yes.
They give you the ingredients and show you how to bake the cake.
Exactly. That's a great way to put it. And for those who prefer to learn by seeing, they even have links to YouTube videos.
Oh, cool.
Where you can see the code in action.
That's good teaching right there, meeting learners where they are. And get this, they even offer AI-powered support using Poe and ChatGPT-4.
Wow.
It's like having an AI tutor on standby
That is very innovative.
to help you build AI.
It really shows how dedicated they are to making AI accessible to everyone.
I'm sold. So where do we even begin? What's a good Hello World project for someone, just dipping their toes into this K-CAI NEURAL API?
Well, the documentation eases you in with this nice, simple neural network. It takes 2 inputs and gives you 1 output.
Okay.
It's a great way to learn the basic building blocks of how these networks work.
2 inputs, 1 output. Okay, I think it can handle that. But let's be real. I haven't exactly been in a computer science class lately.
Right.
Will I need to dust off my old textbooks for this?
No, not at all. They break everything down in a way that makes sense, even if you're a little rusty on the details.
Okay, 2 inputs, 1 output.
Yeah.
Sounds simple enough, but what does that actually look like in the code? What are the ingredients in this neural network recipe?
Well, they start you off with something called TNet input.
Okay.
This represents the input layer of your network where you feed your data in.
TNet input makes sense. It's like the welcome mat for your data.
Exactly.
So what happens once the data is inside?
That's where like the real magic of the neural network happens.
Okay.
In this example, they use something called dense layers to process that information.
Okay.
Specifically, they're using TNNet Full Connect RealU with 32 neurons each.
32 neurons. Okay.
You can think of these dense layers like a network of interconnected nodes.
Right.
Each one is performing calculations on the data.
So each neuron is like a little mini processor,
Yeah.
crunching numbers and passing the results on to the next layer.
Exactly. And the RealU part of that TNNet Full Connect RealU, that refers to what's called the activation function,
Okay.
which basically introduces nonlinearity into the network.
Got it.
Without getting too technical.
Yeah.
It basically allows the network to learn more complex patterns.
Okay, so we've got our input layer, we've got our dense layers processing information.
Right.
What happens at the end of the line? How does the network actually give us an answer? How does it spit out a result?
Well, for this simple network, they use TNNet Full Connect Linear for the output layer,
Okay.
which takes the processed information from those previous layers and gives you your final result.
So input, process, output.
Exactly.
It's amazing how this API, it's like it mirrors the way our brains work,
Yeah.
breaking down these complex tasks into smaller, more manageable steps.
It's a really cool illustration of how neural networks are structured and how this API makes it surprisingly intuitive to actually build them. But this is just the tip of the iceberg. Keep in mind, this 2 input, 1 output example,
Right.
this is like a very basic starting point.
Right.
The documentation, it's got a bunch more basic examples to really help you solidify your understanding.
Oh, really? What kind of examples are we talking about?
Well, they show you how to build a single neuron network,
Okay.
which is about as bare bones as you can get.
Like the neural network equivalent of a single-celled organism.
Exactly. They also have one where you can teach a neural network basic trigonometry,
Oh, wow.
like calculating the hypotenuse of a right triangle.
That's pretty cool. So you're not just talking about neural networks in the abstract, you're actually seeing them learn these like fundamental concepts.
Yeah, and it really shows you how these networks can be trained to perform all sorts of tasks, from simple calculations to really complex pattern recognition.
Right.
And they even have examples for tackling Boolean logic
Okay.
with like AND, OR, and XR functions.
Wow, they're really covering all the bases here.
Yeah.
So we've got our basic building blocks. But what about the data itself? Because neural networks, they're all about data, right?
Right.
So how does the K-CAI Neural API actually handle all that information that these networks need to learn and to make decisions?
That's where volumes come in.
Volumes, okay.
They're the backbone data structure of this whole API, and they're really key to understanding how this thing works.
Okay, help me wrap my head around this. What role do they play?
So imagine you need a really flexible way to store and organize all the data that your neural network is going to be crunching on. That's where volumes come in.
Okay.
They're kind of like supercharged container that can hold information in all these different dimensions.
Got it.
And this makes it really easy for the API to work its magic. And the workhorse for all of this is the TNNet volume component.
So if I'm understanding this right, these TNNet volume things, they're like the fuel that powers the neural network engine.
That's a great way to put it. And the cool thing is the K-CAI Neural API makes it really, really easy to work with these volumes.
Yeah.
You can access them as like 1D, 2D, or even 3D arrays depending on what you need.
Okay.
So you can represent your data in a way that makes sense for the problem you're trying to solve.
Right.
Whether it's a simple list of numbers,
Right.
a grayscale image,
Right.
or even something way more complex.
Okay, that makes sense. But you said something earlier about these volumes being supercharged. What did you mean by that?
Well, one of the coolest things about these volumes is that they're built for speed.
Okay.
They use something called advanced vector extensions, or AVX.
Okay.
And that lets your computer process data in parallel,
Got it.
which means they can handle huge amounts of data way faster than traditional data structures.
So it's like having a multi-lane highway for your data instead of a single-lane road.
Exactly. And if you're lucky enough to have hardware that supports it,
Yeah.
they can even tap into OpenCL,
Okay.
which offloads computations to your graphics card to make things even faster.
They really thought of everything.
They did.
So we've got our data organized, we've got the basic building blocks in
Yeah.
place, but something tells me we're just scratching the surface of what's possible here, right?
You're absolutely right. This is where we start exploring the true power and flexibility of this API. So far, we've just been talking about simple single-layer networks.
Yeah.
But the really cool thing is this API lets you build much more complex architectures just like the human brain.
Okay, I'm listening. Let's talk about those more complex architectures. What are we dealing with here?
Well, so just like our brains have all these different regions that are specialized for different tasks.
Right.
Neural networks can have different types of layers.
Okay.
And each one is designed to process information in a very specific way.
So like different departments in a company, each with their own area of expertise.
Exactly. And the K-CAI Neural API, it's like it gives you this toolbox full of all these different layer types to choose from.
Okay, I'm ready for a tour of this neural network toolbox. What kind of layers are in there? All right, give me the rundown. What's in this neural network toolbox?
Well, we've already talked about those dense layers a bit.
Right.
Those all-rounders like TNNet Full Connect Linear,
Yeah.
TNNet Full Connect Real U, and TNNet Full Connect Sigmoid. These are really useful for general processing and connecting everything up.
Right, like the glue that holds the whole neural network together.
Exactly.
What else is in there?
Let's talk about convolutional layers.
Okay.
Like TNNet convolution.
Convolutional layers. Those always sounded kind of intimidating to me.
Yeah, they can be powerful.
Is this where I need like a PhD in mathematics to understand what's going on?
No, not at all.
Yeah.
The K-CAI Neural API, it really simplifies things.
Yeah.
Imagine you've got a detective and they're scanning a photograph and they're using a magnifying glass to look for specific details.
Hey.
That's kind of what a convolutional layer does.
Got it.
It uses these little filters.
Yeah.
And they kind of slide across the image and they can pick up on patterns, edges, things like that.
So instead of trying to analyze the whole image at once, it breaks it down into smaller chunks.
Exactly. And just like with the dense layers we talked about before, the API gives you different types of convolutional layers.
Okay.
You've got TNNet convolution linear,
Right.
TNNet convolution real U, and even ones that are specialized for different tasks.
Wow, there's so much variety here.
There's TNNet group convolution layers.
Yep.
Those are really good for more efficient processing.
Okay.
And then there are TNNet locally connected layers, which you can use if you need to focus on features that are specific to a certain position.
Wow, it's amazing how much variety there is.
Yeah, the options can seem almost endless.
So after these convolutional layers do their thing and find all the important features, what happens next?
Well, sometimes you have way too much information.
Right.
And you need to condense it down to just the most important parts.
Yeah, makes sense.
That's where pooling layers come in.
Okay.
Like
yeah.
TNNet pooling.
TNNet pooling. Okay.
They help simplify the data, and that makes it easier to process, but without losing those critical features.
So it's like summarizing a really long, detailed report into a more concise executive summary.
Exactly, you got it.
Oh.
And just like we were talking about with the other layers, the K-CAI Neural API offers different types of pooling.
Right.
You've got TNNet Max Pool, TNNet Min Pool, TNNet AVD Pool. Each one has its own way of summarizing the data.
Okay.
And they even have these cool combinations like TNNet Min Max Pool and TNNet AVG Max Pool, which kind of combine the best of both worlds.
They really did think of everything.
They did. There are so many options to explore.
This is a lot to take in, but it's really cool. What other tools do we have in this neural network toolbox?
Well, we can't forget about normalization layers.
Okay.
Things like TNNet Channel Zero Center and TNNet Moving Steady Normalization.
Okay.
Those are super important for making sure that the whole training process goes smoothly.
Okay.
Think of them like the sound engineer at a concert.
Okay.
They're making sure that all the instruments are balanced and the music doesn't get all distorted.
Normalization layers.
Yeah.
The unsung heroes of neural network training.
Absolutely.
So we've got layers to process features.
Right.
Layers to simplify data, layers to keep everything in check.
It all works together.
It's like building this well-oiled AI machine. What's next?
Believe it or not, we've only scratched the surface.
There's more.
The K-CAI Neural API has even more advanced stuff, like data augmentation,
Okay.
which helps you artificially increase like the size and the diversity of your data for training.
Data augmentation. So it's like cloning your data, but with slight variations to make it even more robust.
Exactly. And then there's support for really cool stuff like multi-path architectures,
Wow.
like DenseNet and ResNet.
DenseNet, ResNet, those sound intense,
They are super powerful.
but really, really cool. It's like leveling up your neural network game.
It really is. And on top of all that, if you're dealing with truly massive data sets,
Right.
the API has built-in support for parallel computing.
Okay, that's amazing.
So you can train your models way faster by spreading the work across multiple processors or even GPUs.
This API sounds insanely powerful.
Mm.
But with all this flexibility, all these advanced features, where do we even start with training a neural network? How do we plug in the data and tell it to learn?
That's where the neural fit unit comes in.
Neural fit, okay.
Yeah.
So how does this work? Is it like a one-size-fits-all kind of approach?
Not at all. The K-CAI NEURAL API, it's got different tools for different needs.
Okay, great.
So for things like image classification, there's T-neural image fit,
Okay.
and that even uses those data augmentation techniques that we talked about, like flipping, cropping, resizing images, all that good stuff. And it does it all on the fly.
It's like a training montage for your neural network, but with like extra style points for efficiency.
Exactly. And then if you have data sets that fit in RAM, there's T-neural fit.
Okay.
And if you're working with those really huge data sets, there's T-neural data loading fit, which processes everything in smaller chunks.
They really did think of everything. But do we have any control over the training process? Or are we kind of stuck with just the default settings?
Oh, you have a ton of control. The API lets you customize pretty much everything, from the learning rate that's like adjusting how fast your network learns,
Okay.
to some more advanced stuff like learning rate schedules, which actually change the learning rate over time to help you get the best possible performance.
Learning rate schedules.
Yeah.
So that's next level stuff, huh?
It's like having a personalized workout plan for your neural network. You're pushing it to its limits, but not overdoing it.
This has been an amazing deep dive. I feel like I've learned so much.
It's been fun exploring it with you.
My brain is definitely full.
I hear that.
But I have to ask, with all this power, all this flexibility, what's the catch?
The best part is there's no catch.
Really?
The K-CAI NEURAL API, it's designed to be easy to use and approachable no matter your skill level. The only catch, if you can even call it that, is that you might find yourself spending hours and hours experimenting and building your own AI projects just because it's so much fun.
I can already feel the hours slipping away. This API is a real game changer. It's making AI development accessible to so many more people. It's really exciting to think about all the amazing things people will create with it.
It really is. That's what makes this field so incredible.
Yeah.
With tools like this, the possibilities are pretty much endless, and we've only just begun to explore what we can do.
So for our listeners who are ready to jump in, what's the best way to get started with the K-CAI NEURAL API?
Dive right into that documentation. They've done a phenomenal job explaining everything.
Yeah, they really have.
And they've got tons of helpful examples to get you going.
Definitely.
Don't be afraid to play around, try new things, and most importantly, have fun with it.
And who knows, maybe the next big AI breakthrough will be built with Pascal.
Yeah.
Thanks to the K-CAI NEURAL API and a listener just like you.
Absolutely. Until next time, happy coding.